Hi and welcome. My name's Michael, and in this lesson we're going to take a look at classful networking. While something of a legacy concept now, classful networking still persists in network documentation and examples, and I've included it because I think it's important to understand what it is or what it was for the context on IP assignment strategies. So let's get started. So I'm here in the interactive diagram on the classful networking section. And so a quick caveat, currently all routing on the internet is performed without classes, as prefix links are explicitly communicated as classless. That being said, there are still organizations, entities out there that make use of classful networking, particularly internal schemes and things like that. So networks were assigned using a class system. A Class A network contained over 16 million addresses. A Class B network contained over 65,000. And a Class C network contained 256 addresses. These networks could then be subnetted into smaller network segments. And this is a system that came about prior to private IPs really being a thing. It predates NATing, which is network address translation, permitting you to have multiple internal IPs NATed to a single external IP. So this really was about giving organizations an appropriate amount of address space per their size and requirements. So a small organization, a very small organization, might receive a Class C public network. A large org would get a Class B, and the largest of organizations would get Class A. So let's take a look at the classes. A Class A is defined as a 0 in the leftmost bit of the first octet, which is going to equal anything from 0.0.0.0, right, because it's a 0, all zeros, to a 127.255.255.255, because above 127 would be a 128, and that would be a 1 in the 128 column here, and Class A is defined as a 0 here. So if we were subnetting a Class A, we're working with the first 8 bits as the mask, so the first octet is masked. And so in terms of subnetting, we can start with 255.0.0.0, which can be written as a /8. So that is all first 8 bits. So the whole first octet is masked off. The result of that is going to be one single network with over 16 million hosts. That's a very large network. So we can borrow some bits from the host portion of this Class A network. We can't mess with the network portion because that's the master network. But if we're subnetting it down, we can borrow some host bits from the host section. But what if we want to mask off the first 9 bits, which will be written as 255.128.0.0 or a /9? Now we have 2 networks with a little over 8 million hosts each. Likewise for 10, now we have 4 networks. You should see a pattern here with 4 million. So as we mask from left to right, we're doubling the size of networks and halving the size of hosts. And so we can jump all the way here to a /17. We have 512 networks with 32,000, a little more than 32,000 hosts each. And we can take this all the way to a /30, where we have over 4 million networks with 2 hosts each. So all that is to say, Class A is a lot of space. A Class B is represented as a 1 in the leftmost bit of the first octet, followed by a 0. So this is going to give us an address range of 128.0.0.0 to 191.255.255.255.255. Remember, to get to 192 would require a 1 here, and we can't do that to be classified as a Class B. So back to subnetting. We can start off with 255.255.0.0. That is the general net mask of a Class B network. It could also be written as a /16. That's one network with a little more than 65,000 hosts. If we move that to a /17, we now have two networks with 32,000 hosts. If we move that to a /24 or a 255.255.255.0, we now have 254 networks with 254 hosts each. So again, as we mask off from left to right, we are doubling the size of the amount of networks available while having the amount of hosts each, all the way down to a /30, which is going to give us 16,000 networks plus some at 2 hosts each. And of course, all of those are going to be within the designated range of the Class B network, which gives us a little more than 65,000 IPs to work with. Now, moving to Class C, this is designated as a 1 in the leftmost bit of the first octet, followed by a 1, followed by a 0. This is going to give us 192.0.0.0 to 223.255.255.255. And if we start off with the kind of generic subnet mask for a Class C network, that's 255.255.255.0 or a /24. That is one network with 254 hosts each. So if we want to subnet this out, let's say we want 6 networks with 30 hosts each. That's going to be a /27. We can do a /29. That's going to be 30 networks with 6 hosts each, giving us a 255.255.255.248. Or we can do a /30, 62 networks with 2 hosts each. So lots of networks with only 2 hosts. And again, all of the address space falling within the Class C range, which is 192.0.0.0 to 223.255.255.255. So Class A, B, and C were the primary classes of a classful network. Class D was reserved for a discrete multicast network. So if your organization had a defined multicast network, then you might have had clustered nodes as members of that network on a separate NIC that they could use for their multicast traffic. And then Class E was reserved for experimental use. And again, you should see kind of a pattern here when you look at the first octet. So Class A was a 0 in the leftmost bit. Class B was a 1 followed by a 0. Class C was a 1, 1 followed by a 0. Class D, likewise Class E. So again, I'll reiterate that all routing on the internet is performed without classes. Classful networking in and of itself is kind of a legacy concept. And it really went back to how to assign organizations blocks of public IP addresses. So a small company would get a Class C network. You know, a large company would get a Class B network, and the largest of organizations would get Class A's. And as you can see, there are pretty big jumps, right? What if you needed 500 addresses? You know, well, then you were wasting 65,036 of them. You know, what if you needed 100,000 addresses? Well, then, you know, you're wasting 16.6 million addresses. And so as you can imagine, there's an upper limit to how many public IP addresses there are. And as more and more organizations moved to the internet and needed public addresses, the system didn't particularly scale well and has more or less been completely replaced by CIDR, which we'll cover a couple lessons from now. In the next lesson, we're going to cover the all ones and subnet 0. So if you were really sharp-eyed and you were looking back here when I was looking at my Class C example, and we got to the 30 networks with 6 hosts each, if you remember from our subnetting calculation, where we were calculating the number of subnets, we're looking at essentially the same IP range and net mask, and we want 6 hosts, and we ended up with how many? 32. So the discrepancy there is the all ones and subnet 0, which I'm covering in the next lesson. As for now, this lesson is complete. Thanks for watching.